So today we're going to spend our time. We've got 3 problems that we're going to go through today. Only thing that's changing, just a little change today as compared to what we've been doing. Now our leading coefficient isn't going to be 1. It's going to be something other than 1. Process that we use still kind of like what we did yesterday. We're looking for the zeros first. So we're going to talk about where do the possible zeros come from. And then we're going to find the zeros, and then we're going to sketch the graphs today. So remember the possible zeros. Possible zeros we talked about were essentially P divided by Q. Now remember the p-value. The p-value is all of the factors of your constant at the end of it. So it's the factors of those. So the factors of 15 are positive and negative 1, positive and negative 3, positive and negative 5, and positive and negative 15. Those are the factors of our 15. Okay, so that's where our p-values come from. The q-values, remember, are the factors of your leading coefficient. So our leading coefficient in this case is 5. So our possible q-values are plus or minus 1 and plus or minus 5. So when we talk about then our possible ones, you have to remember our possible ones are P divided by Q. So our possible ones then, it's really our p-value over 1 if our q-value is 1. So our possible ones are plus and minus 1, plus and minus 3, plus and minus 5, and plus and minus 15. That's if our q-value is 1. If our q-value is 5, then we've got plus or minus 1/5, plus or minus 3/5, plus or minus 5 over 5. But we already have 5 over 5 listed. 5 over 5 is just 1, so we already have that listed, so I don't need to list it a second time. And then we've got 15 over 5, which again, we've already got that listed when we have our 3 listed. So here are all of our possible solutions, or our possible zeros, for this problem. And again, you have to remember this P and Q. P is not the value of P. It's the factors of P. Generally speaking, guys, you don't have a problem with the P value. That's usually pretty easy. What you forget is that the Q value is the factors of the leading coefficient. So you need to make sure you list those. You don't necessarily need to list them. You can keep them in your head straight, whatever. But again, just understand it's the factors of the P value divided by the factors of the Q value. So there's our listing. Now we got to figure out which one it is. This has been happening the last 2 days. There's an update that I need to do. All right, so now there's a couple things you can look for when you're trying to figure out what I need to look inside this box to kind of try to help to eliminate it. The first thing I kind of look at is I look at these 2 terms, the 5 and the 25, and think about, okay, how do I get from 5 to 25? Multiply by 5. Multiply by 5. Now, if I want to eliminate 1, because if we think about what we're doing, we're bringing down that 5. We're taking 5 times 5. That gives us 25. 25 plus 25 is 50. But if I make it negative 5, I've got negative 25. And then I've got a 0 that comes out. So now I've got a 0 sitting there, and I've got a screen that disappears again. It's been horrible. Absolutely lately. So I have this But now I've got 16, and what do you notice about 16 to 80? Well, you probably don't notice that one, but if I go 3 to 15, that's 5, right? And 16 to 80 is 5 as well. So the first one I'm going to try is I'm going to try negative 5 because that gives me a bunch of zeros. Or it appears as if it gives me a bunch of zeros. And so I try negative 5. I've got 5, I've got 25, negative 16, negative 80, 3, and 15. Again, with the whole goal that I get a 0 down there at the end. So I bring down the 5, that's negative 25, that's 0. That's 0, that's negative 16, that's 80. That's 0, that's 0, that's 3, that's negative 15. So I know that the negative 5 works. So now that I know the negative 5 works, I've got my first factor. Remember, if the 0 is negative 5, our factor is x plus 5. And now my second factor is 5x to the 4th minus 16x squared plus 3. And this is all still going to equal 0. Because we're going to find the zeros, we're going to factor, find the zeros, and graph it. So now I've got a trinomial. So I've got 3 terms. And because I have my x to the 4th and my x squared, I can try to factor this using the x method. Okay? It should be okay. And if we do that, remember a times c is on the top, so that's 15. B value is on the bottom, negative 16. So top is positive, bottom's negative, so these are going to be negative. So negative 15 and negative 1. That works, right? But what do I have to divide by? Okay, my a value for my trinomial was 5, so I have to divide each of these by 5. So now my factors are x plus 5. Now I have to be careful. It's x to the 4th. So this is going to be x squared. Negative 15 divided by 5 is minus 3. Now I've got x squared minus 1/5. Well, remember when you have minus 1/5, remember what that looks like. The 5, the denominator goes out in front of our variable, and then in this case minus 1, our numerator. So now that's equal to 0. We look at the 2 that are sitting there. They can't be factored. They're not differences of squares. So we're done. Now we find the zeros. So this one's pretty straightforward. It's just negative 5. This is x squared minus 3 equals 0. So that's plus or minus the square root of 3. That one's pretty easy. This one, not so easy. 5x squared minus 1 equals 0. Add 1 and divide by 5. So you get x squared equals 1/5. So kind of on the side, so that means x is equal to positive or negative square root of 1/5. But remember from a long time ago, that's the square root of 1 over the square root of 5. The square root of 1 is 1, so we have 1 over the square root of 5. Can't have that. What do I have to multiply both the numerator and the denominator by? Radical 5. So 1 times radical 5, and this is plus or minus, so 1 times radical 5 is radical 5 over radical 25, which is just 5. So there are my zeros. Okay, so we factored it. We found the zeros. Now we're going to graph it. These are all just numbers. Negative 5 is over there. Square root of 3, I don't know, negative, so we're just going to put it like right there and right there. And we can change these to decimals if we need to, just to kind of put them in a better place. The square root of 5 over 5, that's got to be less than 1, right? So we'll put it here and here. And we're just sketching. We look at the degree. The degree is odd, and our leading coefficient is positive. So odd and positive is in the first and the third quadrants. And the multiplicity of all of these is just 1, so it just passes through them. And that's the sketch of the graph, and that's all we're doing. Obviously, it looks a lot different than that. Who knows how high the relative maxes and mins are? We could do it on Desmos, but we're most interested in graphing today. Okay. So you got to be careful when you're doing these today, especially with those leading coefficients. And we're going to do 2 more. I'll have you do both these next 2 by yourselves. But remember, the p-value is the factors of your constant. The q-values are the factors of your leading coefficient. That's where you get your possible zeros from. Okay? So the next one I want you to try, and I'll give you about 4 minutes-ish, 5 minutes-ish. So given this mess, I want you to find all the possible zeros. So you have to give me that list. Plus and minus 1, plus and minus 2, plus and minus 7. You need to give me that list. Then you need to factor it completely. Then find the zeros, and then sketch the graph. Work with the person beside you. Don't do it by yourselves. Work with the person beside you. It'll give you about 5 minutes. So what works? Negative 2. And again, from 10 to 5 to 10, you're multiplying by 2. Put them opposites of each other. Again, I want to emphasize, that doesn't always work. I was relatively nice today when I gave you the problems. So today, this might work. But if that doesn't work, you just got to try other things. So we've got 5, negative 10, 0, 0, negative 2, 4, 0, 0, negative 7, 14. 0. So x plus 2, then x to the 4, did this again. 5x to the 4th minus 2x squared minus 7. It looks factorable. So a times c is negative 35, b is negative 2. So negative and positive, so negative 7, positive 5. Divide by 5. So x plus 2, 5x minus 7, 5x squared minus 7, and x squared minus 1. So far, so good. So negative 2. You'd have x squared equals 7/5. So x equals plus or minus the square root of 7 over the square root of 5. So multiply by the square root of 5 over the square root of 5. So that's plus or minus square root of 35 over 5. And then plus or minus that should be plus 1, shouldn't it? That should be x squared plus 1. So I. Does that look right now? Sorry about that. That should have been x squared plus 1. So here are our zeros. So when we graph this one, we know where negative 2 is. Square root of 35 is just under 6. So this is going to be, I don't know, 1 point something, and negative 1 point something. We have no idea where that goes. Okay, and we're not concerned with that right now. Odd and positive. So this graph is going to do something like this. There might be a little wiggle down here from our I. There might be a wiggle up here from the I. I don't know. There might be a wiggle over there. I have no idea. And you're not going to worry about it. The part that you're worried about is f with the multiplicity of 1. Remember, the multiplicity comes from how many times the 0 occurs. And each of these only occurs once. Questions with that one? All right, the last one. Same directions. Something disappeared, though. I think there's supposed to be a 4 there. Let me double check. Yep, that's supposed to be a 4. Same directions. Find all the possible zeros. Factor it completely. Find the zeros and graph. Again, I'll give you about 5 minutes with this one. All right, here we go. So again, I'm kind of looking at this going, how do I get from 4 to 2? I divide by 2, which is the same thing as multiplying by a half. And I've got one positive, they're both positive, so the first one I'm going to try is negative 1/2. And with any luck, it'll work. With no luck, it won't work, and then you'll sit here and do another one. But of course, I know it works. So that's 4, that's negative 2, that's 0, that's 0, that's negative 26, that's 13, that's 0, that's 0, that's 12, that's negative 6, that's 0. Works. So our first factor. Is x minus 1, x plus 1/2. We can't write it like that. Remember, the denominator goes out in front of our variable, plus, in this case, our numerator. So then we've got 4x to the 4th minus 26x squared plus 12. Now, there's a couple ways you could do this. One, you've got to factor this. What's it have? There's a GCF. What's the GCF of it? I don't think 4 doesn't go into 26. 2 does, though. So it becomes 2x to the 4th minus 13x squared plus 6. Now, when we do the x method for this, you get 12 and negative 13. So negative 12 and negative 1. But you got to divide by 2. So that gives us 2x plus 1 times x squared minus 6 times 2x squared minus 1. Which I think if you left it alone, you got the same answer. It just would have been 24 and, yeah, 2. So this one we already did. This one's easy. X equals negative 1/2. There's your first 0. X squared minus 6 equals 0. So x squared equals 6. So x equals plus or minus the square root of 6. Then 2x squared minus 1 equals 0. So x squared equals 1/2. Which then x is equal to plus or minus the square root of 1 over the square root of 2. So you got to multiply by the square root of 2 over 2. So x is plus or minus the square root of 2 over 2. So here are your zeros. Here, here, and here. Again, they're all real numbers. We're all good? And where they're at, square root of 6 is, I don't know, 2 point something. So we'll say it's there and there. Square root of 2 over 2 has got to be smaller than that. I don't know. Something like that. We're just sketching the graph. Remember, you can change those to decimals to give yourself a little bit better spot. as far as graphing them. Okay. So graphing, polynomials, factoring, finding zeros when the leading coefficient isn't 1. Not the easiest material that we've done all year,